All right, good morning, class. Today's lesson 2.3, the amazing, the incredible, the Venn diagram. Venn diagrams, you've probably heard of these things before. I'm sure you've seen them in different classes. I know for sure in science and biology class, we've talked about Venn diagrams. We're going to talk about those in the math perspective as well, because just like we did in sections 1 and 2, we're talking about organizing sets. And we're going to be doing that here today as well. So the Venn diagram, invented by John Venn, and it's used to illustrate different ideas. We've got to talk about some of the definitions first and kind of lay the groundwork of what it is we're seeing here. And so you can see the rectangle around the outside includes universal set. That's kind of all the things that we're looking at. So for this example, a universal set, it's going to have, looks like stuff that lives in the ocean and, fish and whales. We use circles, however, to represent different subsets within our universal set. You can see here we have a whales subset and we have a fish subset. And within those two subsets are the different characteristics. So that's how you use a Venn diagram. And in the homework, you're going to see a couple more of these coming up. We have to continue talking about the different types of Venn diagrams. The leftmost one here you can see is what's called a disjointed. So this is disjointed. There's no overlap going on here. The second one over, we call these subsets. A subset means that A is a subset of B. That means that all the things in A are also inside of B. Equal sets, you can see here, A is equal to B, so they both are showing the exact same thing. And so you can see how they're just overlapping perfectly. And then lastly, we have what are called overlapping sets. And this is kind of the most common one that we see, where you've got some things here, some things there, and where they cross goes in the middle. So we'll talk more about that and look at some examples. Here we go. Complements. When we talk about complements, they are a complement of set A is the set of all elements in the universal set that are not in set A. So we have our set, that's A. Then we have the complement to the set is everything outside of A. So this is our set. And this is the complement to the set. You can see we put this little apostrophe on the A to signify a complement. In a Venn diagram, as you're doing your homework, you can shade using shading to show the difference between the set and the complement to the set. Let's keep her moving. Whoops, it's me. So here's example number 1. In example 1, you can see we've got this diagram here. We've got an area shaded on the outside and a set represented on the inside. For this example, first question is, what is the universal? What are we looking at here? Well, as you can see, we're looking at all the natural numbers. That's what that little n means. All the natural numbers. Next question, what is set A? Set A. We see set A. Looks like we're counting up here. So easiest way to say that is set A are the even numbers. And then lastly, what is the complement to set A? The complement to set A are all the numbers that are not part of set A. So that would be, you guessed it, the odd numbers. So as we look at diagrams, and we've got a couple more coming up here, remember, the universal is all the stuff that we're talking about, the numbers. It could be all the natural numbers, or it could be other stuff. Set is what's inside the circle. Complement is what's outside the circle. Here we go, example number 1. This one's actually in your textbook, so you can read it in more thorough case if you like. But given that U, so U, if you think about what does that mean? That means that inside of our box, we have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 through 10, all the natural numbers 1 through 10. And given that our circle is going to contain these numbers, 1, 2, 4, 6, find the complement and illustrate the relationship between the universal, the set A, and the complement to set A in a Venn diagram. So as you're filling this out, again, the universal is our outermost part. Inside we have 1, 2, 4, 6. And the complement, that's the part outside of, but still within our universal, would have the rest of them, 3, etc. So I'm just going to show you instead of trying to doodle it with my terrible handwriting. There it is. So again, you can see the set A is 1, 2, 4, 6. The universal numbers include all the rest of them. Well, we've already used up 1, 2, 4, and 6. That means that 3 5, and 7, 8, and 9, and 10 are all still part of that universal number. Let's keep moving. Intersection. This is the more common type that we see. When we see an intersection, we use this special little character right here. This is the intersection symbol. And our keyword here is and. So how you read this, the intersection of sets A and B is the set containing all elements that are common to both sets A and B. That seems to make pretty good sense. Here we have an example coming up where we're going to have a universal. The universal is, again, all the numbers that we're looking at and how those relate to each other. Here we go. So given 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 are what we're looking at. So real quick sketch of that. And this is where I recommend strongly that you do the sketching part just to help you out with this. So that means our numbers 1 through 10 are what we're looking at. And we've got A is these numbers, and B, we have a little blue for B, are these numbers. It's not going to be a very good one. How can we describe some different features? So we'll take a look at the different features here. First, okay, I messed that up. I didn't want to hit undo, but apparently I did. Anyways, let's try a couple here. So if we have A, and we're looking at the intersection of A and sets A and B, I can kind of do it here with the pencil too. What are both in A and B? Well, 1 is in both A and B, and 6 is in both A and B. So that being said, we have the set of 1 and 6 are in both sets A and B. Moving on to sets A and C, well, as you can tell here, set C is the empty set. And that being said, we're going to wind up having just the empty set. Then the complement of set A and its intersection with set B. So whatever is not in set A, let me tag that up here real quick. So the thing's not in set A, so that's going to be 3 is not in set A, 5 is not in set A. This, again, we're diagramming would be nice. 7, 8, 9, 10. But we're also looking for their intersecting with set B. So set B, so they have to kind of be in both. So you can see 3 is in both, 7 is in both, and 9 is in both. So for this example, 3, 7, and 9 are the ones that are in the intersection of the complement to set A and set B. Ooh, a lot of words. Hopefully it makes a little bit of sense. And the last example here, the complement to sets A and the intersection of sets B. So in that line, the things that are complementing of each, that are not part of each, is going to be these sets of numbers. 2, because while 2 is found in set A, it is not in set B. 3 is found in set B, but it is not found in set A. 4 is found in set A, but not found in set B. 5 is not found in either set. 7 is found in set B, but not found in set A. So that means it's a complement. 8, same thing, not found in either. 9, not found in either. Well, actually, take it back. 9 is found in B, but it's not found in A. And then 10, which is not found in either. So this is the complement to A and its intersection with B. All right. Again, check the text if you're not sure. It's going to help more. There's just a couple of quick examples to get you started. The next form we see here is what's called a union. And a union, nice they use the letter, kind of looks like a U, means or. The union of sets A and B is a set containing all the elements that are members of set A or set B or both sets. So it could be part of both sets too, which is kind of cool. Let's take a look at an example. This is, again, directly from your text. This is example number 4. I wasn't able to recreate this very well, so I just did some quick pictures. But using the Venn diagram in 2.9, determine the following set. So the U for this is going to be all the stuff. We've got 9, triangle, the square, the circle, the 3, the 7, the question mark, the hashtag, the 8, all that stuff. So I'm not quite sure whether the dot net. Anyhow, the next one's A and B. So, sorry, B and C. For letter B, we're being asked set A, and what is all part of set A? Well, that's going to be what's inside this blue circle here. And the complement to set B is going to be everything that's not inside the red circle. So we're looking at 9, the triangle, et cetera, et cetera. So you can see set A consists of the elements in regions 1 and 2. So that's all the things that are part of set A. So it's the 9, the triangle, the square, and the circle. The complement of set B consists of the elements outside of set B. So that's all the stuff that's in the, well, they like to use the letters Roman numeral 4 for everything in the universal. It's complementary to all the sets. And then we're also looking at Roman numeral 1, because those are the things that are not part of set B. So that would be the 8, the hashtag, the triangle, and the 9. All right, let's keep moving here. Numbers or letters D and E. What is the intersection of set A and B, and what is the union of set A and B? So we're looking at intersection versus union. Intersection is going to be things that belong to both sets A and B. So it's going to be this chunk right here. Look at the union of those consists of the elements that belong to set A or B. So remember, we're using or here. That's not a very good or. We're using and when we see this symbol. So that being said, we have the union of set A and B consists of the elements belonging to both sets. So that's part 2 here, the square and the circle. Whereas the union, I think I said that wrong, sorry. That's the intersection. Intersection and then union. So here's union, there's intersection. So the union of both is all of it. So it's the 9, the triangle, the square, the circle, the 3, the question mark, and the 7. Okay. The last 2 questions here are on this example, F and G. We're talking the complement to the union of A and B. And then this last one here kind of goes into the other numbers that are left. So we look at this consists of elements in U that are not in in A and B, and thus they're the complement of. So that means just the things that are outside of. So that's 8 hashtag. And down below here, this represents the number of elements in the union of sets A. That's what that little n stands for. It's the number of elements. So in this example, it's 7. There are 7 elements in this union. So we've got 1, 2, 3, 4, 5, 6, 7. So in your homework, you'll have a couple more examples like this. Remember, again, this is the means the number of elements in sets A. So the number of elements in the union of set A and set B is going to be the number of elements in set A plus the number of elements in set B minus the number of elements that are the intersection of sets A and B. What does this mean? This means that we subtract what's in the middle. So here, to get back to this question, if we have this plus this plus this plus this plus this plus this, if we subtract those 2, that's what we're going to get for the leftover. Here's an example. On Westcott Drive, there are 20 white houses. There are 12 houses that have a chimney, and there are 7 white houses that have a chimney. So that's where that union part comes in. The question is, how many houses are either white or have a chimney? So that means the white houses plus the chimney houses minus the white houses that have a chimney gives us 20 white houses, 12 houses with a chimney, minus the white houses that have a chimney. We leave us the grand total of 25. Okay. So there are some good examples in there and some ways that you can kind of look at this as you work through it. But here is the homework. And here's the cool thing. I'm giving you 2 options. So you can pick which option you want. Option A, I'm going to post this on Classroom 2, option A. So option A is the normal homework. So pages 56 to 58, 14 through 66 even. Make sure you show your work. That might include, or probably will include, showing Venn diagrams. However, I'm also going to provide you guys with an option B. Some of you might rather do this instead. Option B are the 10 cards. So there's going to be a student edition. I'll have those in the back of the room. And you can grab that, and they're called the set theory task cards. They look kind of like this. And I'll have posted around the classroom, maybe the hallway. We'll see how it goes, how my spacing goes. But there are going to be 10 questions to answer with cards that go along with it. And those cards and questions will be available. And so you can do either of these, either option A, normal, or option B, the 10 cards. However, as a quick check to see if you watch the video, I'm not going to say anything about option B except here in the video. So good luck, and if you have any questions, please feel free to email me